All right, let's go through the spell work. Number 1, what do they want me to find about this door? The area. Or, sorry, they don't want me to find the area. They want me to find, my apologies. They want me to find the length. They've given me the area. That's this part right here. What else have they given me? The width. How do you find area for a rectangular object? Length times width. Area is equal to length times width. So I'm going to substitute in what they've given me. 10x cubed minus 6x squared plus 5x. That's what they told me the area was. Do I have the length? Do I have something I can substitute in for that? Nope. So I just have to leave that as an L. L times, do I have something to substitute in for the width? That's a yes. What should I put in for the width? 2x squared. So what do I need to do now to isolate the length to get it all alone? Divide. We're going to divide both sides by 2x squared. Does that numerator have a GCF of 2x squared? I'm not going to be able to cancel that out of each piece. So how do I divide this if I can't factor out a GCF? Yes, we're going to separate it out a piece at a time. So I'm going to make 3 separate fractions here. 10x cubed over 2x squared minus 6x squared over 2x squared plus 5x over 2x squared. And then we're going to reduce each one of these fractions if they can. When you look at this first fraction, will anything reduce there? Yes. How does it reduce? 5x. I know that 10 is 5 times 2, so I see that the 2's are going to cancel. I'm going to have a 5 left. And when we have the same variable on top and bottom, we're going to subtract those exponents. Since the 2 is smaller, I'm going to take it away from up here. So I would have 5 and then x to the power of 3 minus 2. So that would just be x to the first power. So that's just the same as 5x. Nice job, Edson. Come over here to this middle fraction. Can that one reduce at all? 3. The x squareds are going to completely cancel since they're identical top and bottom. If I do 2 minus 2, I get 0, so the whole thing goes away. 6 divided by 2 gives me 3. Okay, so I have 5x minus 3 now. And now we get to our last fraction. Can this guy reduce at all? We got 2 parts to each numerator and denominator, right? I've got a number part and then I have a variable part. Can the numbers reduce, the 5 and the 2? No. They will stay the same. So I still have a 5 up on top and a 2 down on bottom. So now I'm looking at the x's. Are those the same top and bottom? Same variable? Yes. Same power? What's the power on the x in my numerator? 1. That's x to the first power. So where's the bigger exponent? On the bottom. That means I'm going to subtract this power from the bottom. What's 2 minus 1? 1. So I have a 2x left on the bottom. And that equals my length. That is my expression here. Is that answer right there a polynomial? How do I know when I look at it if it's a polynomial? What does it either need to have or need to not have? Exponents where? Chris, you started to say it. Where am I looking? What part of the expression do I care about? The denominator. Do we have any variables in the denominator at all? Yeah, I don't have it here, right? Because that has no denominator. No denominator here. Does this have a denominator? Is there an x in that denominator? That right there is the only reason this is not a polynomial. If that x was up on top instead of in the bottom, it would be a polynomial. But when you have it after we've simplified and reduced everything, if you still have a variable in the denominator, it is not a polynomial. So I would say no, there's still a variable in the denominator after reducing. All right. Number 2. What are we supposed to do on number 2? Simplify, yes. What operation is in between those fractions that I'm going to have to simplify first? Division. When you see division, we've got a 3-part step. What do we do when you see division and fractions? Keep, change, flip. So that first fraction I keep, 2x squared minus 50 over x squared plus 4x minus 5. I change this this division into multiplication, and I flip the second fraction. So 2x squared plus x minus 3 comes up to the top, and 6 times x minus 5 moves down to the bottom. Something I want to point out here, it came up in first period and it was a great question. Do not distribute that 6. Because after we do keep, change, flip, what do I have to do to all of the parts of both fractions? Starts with an F. Factor. If I distribute, that's the opposite of factoring. I'm basically creating more work for myself. If I distribute, I'm just going to have to undo it again in the next step. All right, so let's factor all of these things. What's the first thing I go looking for when we want to factor? GCF. Does this first numerator have a GCF?
2x squared.
Close. The 2 part, because 2 can go into 2 and 50. So this has a GCF of 2. So I'm going to take that 2 out. What would I still have remaining after I take the 2 out?
X squared. 25.
Yep, x squared and minus 25. Then I'm going to look at this first denominator. Does this guy have a GCF? No. What about my second numerator? Does that have a GCF? Nope. So I'm going to keep it as is. What about this denominator down here? Not anything I'm going to have to do any work with. Technically, it has a GCF of 6, but they already pulled it out for me, so I don't have to do that. All right, so I've got this x squared plus 4x minus 5 that's still here. I've got this multiplication symbol. And then I have 2x squared plus x minus 3 over 6 times x minus 5. And now we're going to have to factor all the parts. That first numerator, the one that we said had a GCF of 2, can I factor that anymore? The x squared minus 25? I can. What do we call this kind of a situation where I don't have that b value and there's a minus in there? Close. What do you notice about 25? Yeah. It's a difference of perfect squares, difference of two squares. The x squared is a square, and the 25 is 5 times 5, so it's also a square. So that numerator, I'm going to bring my work up here. How will that numerator factor? X plus 5 and x minus 5. And then I look at the denominator. Should I try to factor that? Do I need to try? What do you see down on the bottom that tells me whether or not I need to try to factor it? An exponent. Does it have an exponent? Yep. I have an x squared down there, so I need to try. So I'm going to do my x. Will I need my area model? Do I need to make a box, or can I use the shortcut? Shortcut. So I need two numbers that are going to multiply together to give me -5, but when I add them, I get 4. It's going to multiply to -5 and add to 4. That absolutely still holds true this week as well. You either discipline your phone or you put it up there. Multiplies to -5, adds to +4. 5 and -1 is absolutely correct. So using my shortcut, since you said it's a +5, that's going to be x plus 5. The -1 means it'll be x minus 1. Then we have our multiplication sign. We have our other fraction. Should I try to factor this numerator? I should try. What did you see that told you should try? An exponent. We see that squared there. So I'm going to do my x again. Will I be allowed to use the shortcut on this? No. Why not? Yeah, my a value is not a 1, and I couldn't get it out as a GCF, so it's still stuck there. So I have to multiply the a and the c together. I get -6 up on top. Down on bottom, my b is just a +1. What multiplies to -6 but adds to 1? -2, +3. But now I need to draw my area model because I have to do the whole thing. All right, so I have 2x squared here, -3 here. Those two numbers that we just found, -2x, +3x, and we're going to look at just 2 boxes at a time. Do you guys want to go side to side first or up and down? Because we got to go both ways. Up and down. 2x squared and 3x. What can I take out of each of those? I can take an x out. What about -2x and -3? -1. So x minus 1 is one of those factors. So I'm going to write it down. Now we'll go side to side. 2x squared and -2x. 2x and 3x and -3. What'd you say?
-3.
It's touching a box that's positive, so it has to be a positive, and it's just going to be a 3, not a 3x, because why?
You already have the 3 outside.
Yep.
I mean, x.
They don't both have x's. We have our x up on top and our x above this. Both of these don't have x's, so I can't take an x out there. So 2x plus 3 is my other factor here. I didn't have to do any factoring work here because why?
It's already factored.
It's already factored. There's no x squareds, and it already has the GCF out at the front. Will anything reduce? Will anything cancel? X minus 5s will cancel. It does not matter that they're part of two separate fractions. When we multiply fractions together, we multiply top to top
X minus 1.
and bottom to bottom. X minus 1, yes. And X plus 5. What do I have left in my numerator? Yep, I have this 2 left and 2x plus 3, so I'm going to write that down. So I have this 2x plus 3. What do I have remaining in the denominator? I have a 6 still right down here. Remember that GCF that they took out for me? We didn't do anything with that. Can anything else here reduce or cancel? What'd you say? I can't really touch the 2x plus 3 because he's stuck inside parentheses.
Did you put the 2 on the bottom and the 5? Or no?
Close. I can't move the 2 to the bottom, but I can reduce it or divide both of these by 2. Because I know that 2 is 2 times 1, right? And 6 is what? 2 times 3. If I write it like that, I see that they have something in common, don't they? What do they have in common that I could still cancel out?
2.
The 2 part. So in my numerator, I have 2x plus 3. What's all left over in the denominator? The 3 right here. Can I cancel these two?
Yes.
What operation is going on in my numerator?
Oh, no.
What's right in front of the 3? Addition, a plus. If I have a 3 on the bottom of a fraction, fractions mean what operation? Division. Does division make addition cancel out? Then I cannot use this to cancel out the 3's. This would be my final answer right here. All right. One more thing I want to look at with you guys. If you flip in your books to page 187. Flip forward in your books to page 187, please. Good question. So it tells us right here that rectangle ABCD has an area of 2x squared plus 17x plus 35. Where is rectangle ABCD? Yep, it's this one right up here in the upper left. When I'm talking about area, where do you find area? Inside. So inside here is 2x squared plus 17x plus 35. Do we know anything else about this rectangle? Yes, side AB has a length of x plus 5. So I'm going to go find side AB. That's this side right here. This is x plus 5. What else have they told me in this problem? Yes, DEFG has an area of 4x squared minus 11x minus 20. Where is DEFG? The bottom one. So right down here. So that space inside is 4x squared minus 11x minus 20. Anything else at all that they gave me? Yep. Side DF has a length of 4x plus 5. So that would be right here. What do they want me to find? In part A, what's the first thing they want me to find? The length of AC. Where's that at in my picture? This right here. We have the area for that rectangle, right? Area is what times what? Area is equal to length, oops, not 4, length times width. So I'm going to take what they gave me for the area and I'm going to substitute it in for A. 2x squared plus 17x plus 35. Do I have one side of this rectangle? What is it? X plus 5. It does not matter whether I put that in for the length or the width, as long as it goes in for one of my sides. What operation would I want to use next to get the length all by itself? Division. I'm going to divide both sides by x plus 5. So it's going to cancel out there, which means I probably need to do what in my numerator? Factor it. So I'm going to need to make my x. Will I be allowed to use my shortcut? No, I cannot. Shoot. Okay. Let's make the x first. I need to multiply a and c together. So I'm going to multiply 2 and 35 together. That gives me 70. Has to multiply to 70, but add to what? 17. 10 and 7. So I'm going to use 10 and 7 in my area model that I'm going to draw for this. I feel like I don't have very much room to do this in. 2x squared goes here, 35 goes here, 10x, 7x. We went up and down first on the bell work, so let's go side to side first. 2x squared and 10x, what can I take out of both of those? What can I take out of 2x squared and 10x? I can take an x out. What else goes into 2 and 10? 2. 7x and 35, what can I take out of both of those? Sorry, it's way over here and it's super tiny because I have no room. I'm so sorry. What can I take out of the 7 and the 35? I can take a 7 out. Positive or negative? Positive. It's touching a box that's positive. All right, so I'm working on this numerator right here. And I just got 2x plus 7. Let's go up and down now. 2x squared and 7x. What can I take out of both of those? Just an x. What about 10x and 35? 5. So x plus 5. And it was already over what? X plus 5. And that's going to equal my length. Will anything cancel? Yeah. X plus 5s are going to cancel. So what is my length? 2x plus 7. I know this piece now. Part B, what do they want me to find? The length of side FG. So they're asking me to find this down here now. Do I still use area equals length times width? What do we have? What do we know? 4x. Do I know the area of this rectangle? Yes, 4x squared minus 11x minus 20. That was an area. So I can substitute that in the place of the a. Do I know one of the sides of this rectangle? Yes, I do. 4x plus 5 times my length. Again, it doesn't matter which one I call length and which one I call width. What do I need to do next? Divide. We're going to divide both sides by 4x plus 5. That's going to cancel out here. What do I need to do to that numerator then? Factor. Will I be allowed to use the shortcut on this one? No. No? Okay, fine. So I need two numbers that when I multiply them together, I get negative 80. But when I add them, I get negative 11. What's going to multiply to give me negative 80, but add to give me negative 11? Like 8 and 10 multiply to 80, right? But if I take 8 and 10 and put them together, there's no way with adding or subtracting that I can get to 11. So it can't be 8 and 10. Could it be 4 and 20? Can I take 4 and 20 and get to 11? No, if I add them, I get 24. If I subtract them, I get 16. 5 and something. Grab a calculator. What's 80 divided by 5? 16. So how do I take 5 and 16 and get negative 11? Negative 16. So here's my two numbers that I can use in my area model now. I've got 4x squared. I've got negative 20. And now I just found these two pieces, 5x and negative 16x. What do I have? Let's try this. Let's go side to side. 4x squared and 5x. What can I take out of both of them? I can take an x out. Anything else? And it's okay if the answer is no. Can I take anything else out of 4x squared and 5x? Yeah, just a 1x. What about negative 16x and negative 20? 4, positive or negative? Negative. All right, so x minus 4. Now we're going to go up and down. 4x squared and negative 16x. 4x. What about 5x and negative 20? Positive 5. So 4x plus 5. What was I dividing both of those by? 4x plus 5. And that's going to be equal to my length. Will anything cancel? 4x plus 5 will cancel. And so my length down here, what they asked me to find, is x minus 4. What's the last question? What is the last question? Find the area of what? BDEH. Where's that at? At the top. It's this one right here. They want me to find the area of that. How do we find area? Length times width. Do I know the length or the width of this rectangle? Do I know how big this side is right here? It is going to be x minus 4. In rectangles, opposite sides have the same length. So this side over here is x minus 4. Do we know how big this side is? 2x plus 7. So what do I need to do to find the area? Multiply those two together. Area is equal to 2x plus 7 times x minus 4. What do I need to use in order to do this? What property do I need to use here? Starts with a D. Not division.
Subtraction.
Distributive property. I'm multiplying these two polynomials together here, so we are going to distribute. I need to take this 2x, and it has to distribute to both parts here. What is 2x times x? 2x squared. But then I have to take the 2x and also distribute it to the negative 4. What's 2x times negative 4? Negative 8x. I still need to distribute. This time I have to take the 7 and distribute it. What's 7 times x? Yep, plus 7x. And then I take the 7 and I distribute it to the negative 4. Negative 28. Are there any like terms that I should put together? Negative 8x and 7x. I don't have a like term for 2x squared, so it stays the same. What do I get when I put the negative 8x and the 7x together? Negative x. Do I have a like term for the negative 28? Nope. Bring it down. That is my final answer. Nice work. You guys have the remainder of class, which I understand isn't a ton of time, but you have the remainder of class to work on a 5-question multiple choice review assignment in Canvas.
Wait, what I test tomorrow?
No, your test is Thursday.
This the review for the test?
I'm going to pass out the paper review. This is just a real quick kind of skills check thing.
Oh,
Just 5 questions, multiple choice. It's due by the end of the day today because I want to see going into our review where are our strengths and weaknesses.
okay.
All right.
So will our test look like this? Not like this, but like.
I'm getting ready to pass out the paper review, and that'll give you a real good idea of what you can expect.
Okay.
Yep. There's nothing on the test that is not on the paper review that I'm passing out. You guys do get to use a cheat sheet this time as well, just like last time. One side, I'll pass those papers out tomorrow. On Canvas, if you click on the big red button that says click here for today's lesson, you will see an assignment that says Operations on Rational Expressions Review. There's a link to it on our daily page. It should also be showing up in your to-do list on Canvas. This is the 5-question multiple choice that's due by the end of the day today. Shouldn't be super long, and you have an unlimited number of attempts at it even after today. But I want to get a first submission down so that I know exactly where we need to focus tomorrow. Go ahead and get started on that. And after I get these out to everybody, I'm going to pass back your tests from the last unit so that you guys can see your scores. If you have not completed that test yet, I'm going to ask you to step into the hall. Hopefully everybody has a paper copy of the review now. Again, if it's not on the review, it will not be on the test.